Hello once again, this is KP the Math G. Let me get a little bit away from the camera so you can see me a little better. I don't have my KP the Math G shirt. After four wears, it's time to wash it. So I'm going to probably wash this by hand. I don't want to mess up this emblem if you can see real closely. I had a student to do this for me and made one for myself and my wife, and delighted to have it. I may have to see if I can get her or someone else to make some more of these. I'll probably get her. She's one of my former students, really good student, and I had a lot of good students in the past. Actually, when you come to think of it, KP the Math G was not my idea. The kids started calling me KP, and then I started doing videos. Well, they wanted to just say the Math G. Where that came from was from one of my former students in a class, and said, "Why don't you just call yourself the Math G?" And I said, "Well, okay." So I guess because it rhymed, I don't know, KP the Math G, but I said, well, what does G stand for? Well, it could be anything you want, they said. So, guru or genius. I don't recall myself being a genius at any rate, at any level, but I do aspire to be a good person and to give you the best I can give you here. I'm going to tell you there are teachers out there, and maybe even some really sharp students who have a little better, grip of this than I do, especially the BC students. But needless to say, I'm going to give you my best and give you my all, and that's the best I can do. But I know I'm going to, if I'm wrong, I'm going to make it right. So what we're doing today is, and that's enough of my KP the Math G story. Other than this, one thing, I don't know if you can see this, but this was at Chuck E. Cheese's, and this is a picture of me wrestling with my grandson. I got him in position just in time for the picture to take. So that was at Chuck E. Cheese's. We got a beautiful grandson. He's 2 years old now, and got other grandsons too. One is 10, and another one is, well, 6, I believe it is. Yeah. Okay. We want to derive the slope of the tangent line, and this is a curve here. We can call this F. Okay, if you will. This is a point on F. This is this blue line is a tangent line. A tangent line just touches the edge of the curve, whereas a secant line goes through it in 2 points like this. This is the secant line. Well, what happens is, guys, is that when we're talking about limit, what happens is this secant line, you can draw another secant line and another secant line and another secant line, and what happens is this secant line gets closer and closer and closer to this tangent line, almost to the point of coinciding, and that's where we get limit. It's not so far, it's not so much that it's this far away, but now it's this far, then this far, then this, and almost to the point of coinciding with this tangent line, and that's where the limit comes from. That's actually where we get the derivative, or not, well, it does become the derivative, but the limit of the secant line is actually the tangent line. This right here is the slope of the secant line. If you notice real carefully, we're going to make this point E, which is x2, y2, okay? This is x1, y1. This is the point. This is just a point here, and of the tangent line. And so the slope of this is y2 minus y1 divided by x2 over x1. So what we have here is F at x minus F at c over x minus c. So this is the slope of the secant line. But when we take the limit, as we're going to see when I flip this board over, okay, that when we take the limit, that's when we're moving that secant line closer and closer and closer and closer to the tangent line. Now we have the limit as x approaches some c, 3, 4, negative pi over 2, whatever, f at x minus f at c over x minus c. That's the limit of the secant line. Now that becomes now the slope of the tangent line. So what we're going to do in just a moment is we're going to find an equation of the tangent, of the tangent line. Yes, by the way, I almost forgot, I'm wearing hats now, and I'm getting my other caps cleaned up. They've been kind of out in the garden getting dirty. My wife and I do garden work, but yeah, I do have this hat on. I look a little bit like a sailor today, but that's okay. I don't mind. Okay. Anyway, back to business here. So let's see here. If we make this x minus c be equal to h, notice that the limit has been as x approaches this c right here, but now x is going to approach the h, so now the limit is it's going to be as x approaches c, but remember we let x minus c be h, so now as x approaches h. Okay, now what happens here is that x minus c is equal to h. Okay, and then we have this here. Well, what do we have here? Well, let's see, we're going to let x be equal to, if we solve for x, if we add c to both sides, we got c plus h right here. So then this becomes now f at c plus h minus, let's see, hold on, let me see. And I just knocked over something just now. I think, yeah, I'm just trying to think just a little bit. Give me a second here what I've got going on right here. Okay, so minus f at c. Alright, minus f at c. Alright, so I've kind of read this, I had to read this correctly. I do have this correct now. Okay. Okay, so that's what we have here. If we replace every c with x, you have something that's familiar that you've been introduced to at the beginning of this school year. X approaches h. F at x plus h minus f at x over h. By the way, incidentally, when you think about this, we can use this, by the way, and we'll see later on, to find average velocity. The limit of this becomes instantaneous. Well, actually, without the limit, we can find the average speed or the average velocity, but with the limit we can find the instantaneous and so on. And actually the limit does lend itself to what we call the derivative, which we're going to look at later on. Okay, so let's take a look at one example that I have. We're going to use this to come up with the, and actually this for that matter, I think we're going to look at this as well. to find the equation of a line tangent to a certain curve. Okay, so let's go ahead and get started with that. Okay, so let me find my eraser, and if I don't, I have something to wipe with, and without wasting time. I think probably. If I have a downfall, it's me trying to stay organized. Ouch, that hurt. Don't laugh too hard, students and teachers. If you're watching this, got my hand stuck right in there. Boy, that hurt really good. Okay, well, otherwise I wouldn't be saying ouch, would I? Okay, so what are we doing here? As a matter of fact, let's go ahead. We've already made this derivation here, so let's just erase it all. And maybe in a few minutes my fingers will start feeling better. Okay, alright, so let's see. We want the equation. What we want to do is find the equation of the tangent line, or of the tangent line to this curve. Alright, alpha x is equal to squared plus 3x 7 at, alright, the point is -3, 4. Alright, very good. That's starting to get it back again. Starting to feel a little better. Whew, I'll never do that again. I've got to remember to keep my hands out of that. Alright, well, let's go ahead and get started. And what we're going to do here is we're going to use this limit as x approaches h. Now, what is it? It is x plus h minus, it's L fet that, okay, not just x minus plus h, but L fet x over h. Alright. Well, what we're doing here on the first one, notice right in here, x plus h is in the place of these x's here. So when we do this limit right here, as x approaches h, we're simply going to start off saying, well, something squared plus 3 times something plus 7, and then of course minus, and I like to do this immediately. When I have a minus sign, you can do a parentheses or a bracket. I like to do that. Keep that separate, and then I'm just going to say x squared plus 3x plus 7. After all, whoops, start off with a bracket. I need to end up with, isn't that alpha x right there? Yeah, that is alpha x. That's the whole thing right here, isn't it? So that's going inside here. This part right here is going in each one of these x's, so that we have x plus h squared plus 3 times x plus h. Okay, oh, by the way, all of this is over h. Somebody would have caught me on that, I'm sure. Okay, let's do that some more. Wow, we got to expand this. By the way, it's let's put it up here. It is actually x plus h times itself twice. Always remember you can do that. X times x is x squared. So what we have here, let's just put it down here as we go. As x approaches h. Alright, so this becomes x squared plus something. Okay. Alright, x times h is xh. Alright, x squared plus xh plus another xh plus h times h is h squared. Alright, so let's write that down. xh plus xh is 2 xh, got two of them, 1 plus 1, and then plus h squared. Alright, now remember we got also 3 times all of this, so plus 3x plus 3h, and then 7 stands alone. Now this negative is distributed across all of this, so it's just, okay, so minus x squared minus 3x minus 7, wow, all over h. Alright, long thing here. The thing about these problems is it's just tedious work, you know, but you got to be really careful, and that's part of the beauty of math, is learning how to be careful, okay, and not careless. Alright, so the limit as x approaches h. Well, let's see, I think we can eliminate some of these. X squared minus x, negative x squared, 3x minus 3x plus 7 minus 7. Notice all of these terms are gone. And now we can simplify this somewhat. 2xh plus h squared. Where else? Got this and this. I got one more. Plus 3h all over h. That looks good. Okay. In fact, we can bring this over one more time. May have to flip the board over. Alright, the limit as x approaches h. Well, it looks like we can factor out a common h. So h times 2x plus h plus 3. Now keep in mind we are finding the slope. So really, the slope of the tangent line. This is not an equation. It is the slope of the tangent line. Okay, well, the h's divide out. I hate to say the word cancel out, but they divide out. And we are left with, hopefully now we can just do this. The limit as x, as x approaches h, 2x plus, now remember, oh wait, I'm sorry, this is not x approaches, this is h approaches 0, isn't it? Yeah, yes, yes, somebody shout through the camera. Alright, h approaches 0. Wow, look at that. H approaches 0. Oh my goodness. Well, it's not a fatality here. At least I'm not falling to the floor dying here. But I gotta quit being so careless. Alright, as h approaches 0. Now we're good. Woo, okay. And teachers, if you're watching, have mercy. Alright, there it is as h approaches 0. Now this is the slope, which is just 2x plus 3. We're going to flip our board over again. 2x plus 3 is the slope. Remember, we're going through negative 3, 4. 2x plus 3, negative 3, 4. Okay. 2x plus 3, negative 3, 4. Let's write it down. The slope is 2x plus 3, and going through negative 3, comma 4. I do believe I got that. Let me look on the other side just to make sure. It's going to be upside down, but it's okay. Alright, let's see. Double check. Alright, let's see. Negative 3, comma 4 is correct. 2x plus 3 is also correct. Okay. Alright. Whew. Okay. eraser, and I bet it's on the other side, or wherever. Yep, it's right here. I'll tell you what, I'm glad that my head is screwed on, because if it weren't, I think I'd lose it too. Okay, let's erase all of this. Gotta have a little humor in here somewhere, you know, of course. Pinching my fingers just now was not very humorous, but if you laugh, that's okay. I won't know anything about it. Okay, there we go. Now we're in business. Okay, we are in really good business now, because we're looking for the equation. Remember, we have the slope right here. Okay, so now here we go. Y minus y1 is equal to m times x minus x1. Y'all need to know that by heart. Okay, y minus 4 is equal to the slope, which is, well, 2x plus 3 times x minus x1. Okay, we know that the slope is this. Okay, or am I leaving something out? Okay, 2x plus 3. Okay, so let's see. At x equals -3. All right, so let's see what we got here. As a matter of fact, let's just figure out what the slope here is. We got 2 times -3. This is at equals -3 plus 3. That's -6 plus 3, which is -3. Okay. And then, of course, this x value is still -3, so here we go. Y minus 4 is equal to -3 times x minus -3. Okay, that's it. Now, sometimes teachers will tell you, once you get your equation, you don't have to do any more. Okay, well, that's fine. I'm going to go ahead and take a risk that I'm not going to make a mistake. And that's what we're doing, is risking that we won't make a mistake. Okay, now if you want to do it like that, I think sometimes they accept that as well. As long as you're doing it correctly, it's fine. But I don't know, but once you get down to here, maybe you're all right with that. Okay, so that right there, dear ones, that is your equation. Now, of course, we can go further. Y is equal to -3x minus 9 plus 4. Y is equal to -3x minus 5. And that's what I got. Okay. Again, I think we are good to stop anywhere here, but this is fine here. If they wanted in y is equal to mx plus b, that's what we're to do. Okay. If not, then probably we can just leave it like this from the start. Okay, that's how you can do it that way. Alright, and there is another way we could have done this as far as finding the slope. I don't know if I want to go through all of that, but I'm going to show you at least in part. Here's the answer here, by the way. Okay, we know that the slope is -3. We're going to leave that up there. Okay, so here's another option that we could have taken, an alternative route. We could have said that the slope is equal to the limit. Now, as x approaches -3, okay, f at x minus f at negative 3 over x minus negative 3. Alright, and of course that is actually remember that's the limit of the secant line, which is actually the slope of the tangent line. Okay, so that is another way that you could do this. The original problem was f at x is equal to x squared plus 3x plus 7. So we could plug that into this f at x right here, and then plug f at negative 3 into this here. Negative 3 squared plus 3 times negative 3 plus 7. That's going to be 9 minus 9 plus 7, which is just 7. So that just equals 7. And so what we have here then is the limit, the slope is the limit as x approaches negative 3. The reason that it is approaching negative 3 is that we are just looking at the slope of the secant line, which is actually the limit. The limit makes it the slope of the tangent line. Okay, that's the alternative way of doing it there. Remember, we got that other formula from this anyway. We derived it from this. Okay. And if you wanted to make that plus 3, okay, you can do that. Okay, so what we have here is x squared plus 3x plus 7. We already know minus 7, okay, over x plus 3. And notice that goes away. And the limit as x approaches negative 3 is going to be, and look at this right here. We can go ahead and take out an x. I'm trying to do this for lack of time. Plus 3 over x plus 3. I believe if I've done everything correctly. Now then, this is, remember the slope. So m is equal to the limit as x approaches negative 3. Oh well, that's just x. So then that's just equal to negative 3 because I can plug in the negative 3 in there. And that's what I got here. So if you wanted to find the slope of the alternative way, that's another way that we could do that. Okay, that's pretty much all that I have for this lesson. In the next lesson, I'm going to look at the derivative. We're going to finally get into using this formula that we just had, just showed a while ago, and we're going to look at the derivative from that slope. Okay, and get where you don't have to use the limit. We're going to find another way to find the derivative. Okay. All right. So thank you very much. Thank you for your patience. Thank you for not laughing too hard at my fingers getting crushed. These two here, oh, they're in good shape now. Thank you for being patient with me. I appreciate all of this. This is KP the Math G. If you want to subscribe, you certainly may. If there is a comment section, please feel free to comment at any time. And if there's any way that you can show me a better, easier way, please do. I'm open for suggestions. Thank you very much. I appreciate every one of you.